Hey everybody, this is Larry. Oh look, the contest in 12 hours. So it's day 8 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem. 2551, put marbles in bag. Seems like this is a recent contest problem, maybe not that recent. Oh, I mean, like half a year ago is pretty recent. Let's see if I remember it, or hopefully not. But you could probably also search for it and you'll see me during the contest if you want to see something even more live, I guess. Anyway, let's see. Let's take a look at this. I could probably articulate it a little bit differently this time. You have k backs. You're given 0 index integer array weights, where weights of I is the rate of ith marble. You're also given the integer k. All right. Divide the marbles into k bags according to the following rules. No bag is empty. The ith marble and the jth marble in the bag, all marbles with an index for I and j. Okay, so that has to be a sub-array of, a chunk. If a bag consists of all the marbles with an index from I to j inclusively, then the cost of the bag is I plus j. The score after distributing the marbles is the sum of all the costs in the k bag. Okay. There's a very weird way of phrasing it, but also, honestly, I don't remember this at all. The first thing I want to do, to be honest, is look at the constraints, because and n is 10 to the 5th, which tells me that I have to be a little bit not careful is not the right word, but I have to think about it a little bit more, right? Because I thought, because if n is very small, there are a couple of dynamic programming-y, recursion-y things that I could do right off the bat. Now that this is n is 10 to the 5th, or 10 to the 5th, what I'm looking for is probably like a linear or n log n adverse type of solution, right? And of course, that requires some sort of observation. So let's see, right? Okay. So we want to return the difference between the maximum and the minimum score. So these things, there are a couple of ways to attack these problems, or maybe not attack, but like these are the things that I think about as options. Not all of them necessarily might lead to a solution, and right now I don't have a solution, even though it's only been half a year. So we'll see if I can, But one thing that I can think about is that, okay, the delta between the max and the minimum, what does that mean, right? That means that possibly we try to calculate the difference, but also possibly maybe we'll try to figure out the max and the min and so forth, right? The couple of ideas that I have immediately, like I said, right, what we're looking for is kind of n log n, and from n log n, then we're basically for n log n, we want some sort of thing that makes it not n square, obviously. And one of the prime candidates is binary search. There are a couple of things that we can do there to play around, but oh, I actually misread this looking at the problem, so maybe that's how. Okay. I actually totally misread this, sorry. Huh. I see. So, okay, no, I I take back some of the words I said. I don't know which ones, but I misread it. I thought that I totally misread it. I thought that given an array, you have, maybe this is the minimum component of the score, and this is the maximum, and the score is the difference between those two. But it turns out that it seems like, and maybe this is why we need to read examples a little bit, just to make sure your understanding is correct before solving it. I'm kind of bad at it sometimes, but sometimes because I'm rushing, right, like during the contest. But it seems like this is just taking the min and the max, so we just have to figure out a strategy for the min and figure out a strategy for the max. And in that way, maybe it becomes two problems, right? Or one problem with two sub-problems. In these kind of things, especially with 10 to the 5th being n, I'm thinking about there's probably some greedy component. It doesn't necessarily be a greedy, like a linear greedy, but some sort of greedy component to a problem. But given the maximum and the minimum, it may be possible that one of them is way like has a greedy solution and the other doesn't, or something like this, right? So we have to kind of be deliberate here. And another thing that I could maybe think about is some sort of heuristic for minimum, and this is based off greedy as well. So yeah, and we're trying to. Oh, yeah, the maximum and minimum. So what is the minimum score, right? The minimum score. I feel like there's I feel like the observation here is maybe we can do some. The one thing that I'm trying to think about in a greedy way is that is some sort of repeated getting minimum, right, or something like this. So with that, I'm leaning towards some sort of heap type solution. But also, honestly, I don't know yet. So this is definitely one that, you know, also maybe shows you that I don't memorize everything. Or even if I tried, maybe I don't actually, regardless of whether I'm doing it. Okay. Minimum. So I think the idea behind, I think one way I can rephrase the problem, or try to rephrase the problem for at least the minimum. Let's focus on the minimum first. I maybe some of the stuff we can use for maximum, but you know, like I said, there are going to be two different things with different properties, some of them overlapping. So let's focus on one of them first, right? So basically, you have an array and some k, right? What does that mean? So what that means is, let's see, and then some k. I mean, what that means is that I'm trying to think whether you always want to take the minimum, right? I think that's something. So with that, and kind of goes into what we were going about recently, is try to figure out an invariant that holds true after taking iterations, right? So that may be like, you know, so like there's a subproblem of k is equal to 2. Now you're doing a subproblem of k is equal to 1, and then right? So then, and if there's an invariant, maybe based off some sort of greedy observation, then you can use it. And yeah, I mean, I kind of can make up something about this particular input, but I'm trying to figure out from that, are there ways to generalize it in a good way, right? I think that's what I'm trying to figure out for this one right now. And maybe I'm trying to think also, can I think about this backwards, right? Meaning that, okay, maybe we talk about trying to repeatedly getting the min, but maybe, you know, and then like doing the rest of the stuff. So okay. I think, okay, so for k is equal to 2, that means we have to put one divider somewhere, right? Like one divider in between things somewhere. And for k is equal to 1, then we have to put, well, 0 divider. Okay, fine, that's a dumb example. But for k is equal to 3, then we have to put 2 dividers, right? Somewhere. And what does that mean for a divider? So a divider is equal to the sum of the two adjacent numbers, right? In the final contribution of the score, plus like, you know, the left and the right. So I think that's it then, right? So we just have to minimize getting for the minimum score, we literally look at all these things, all the in-betweens, and there should be only n of them. And then we kind of repeatedly do that. So then I think that's it. So then we have a heap-based thing where the invariant is that after you divide them, it's still the same problem. That wasn't the min, but let's say we put it here, and then you kind of minimum, and then you kind of return one, because then this contributes a score of 6 from both sides, and at the end you just return the left and the right, which is fine, right? So okay, so minimum I think we get. I hope that was clear. I think the other way, I think let me try again to repeat it, because I'm not sure that I got it clearly the first time, because literally you're seeing Larry solve it live. Okay, so basically you have k-1 dividers, and each divider's contribution is basically the left and the right of the divider, because then that means that they become the component of what do they call it? Of a bag, right? Okay, and then we just try to minimize it. And for max is the same, right? Is it the same? Because we just take the biggest. We have no control with the left and the right, and then we just keep taking the biggest every time. And I think that's it. So yeah. Okay, so yeah, so I think that's it really. So then now we can do something like for xy in SIP of weights. So this looks at adjacent things, right? So we can so yeah, okay, so scores is equal to scores dot append x plus y for this reason, and I think also this is one of those things where if I have to guess and suspect, you look at someone's code without an explanation, it looks ridiculous because you're like, why is this happening? And you have to figure it out. But with the right understanding, you're just like, oh, this is obvious, right? So then now, I mean, I was going to say heap, which you can still do heap, but I think now we just kind of sort it. Because once you sort it, then you take, so what's it? Mini is equal to 0, maxi is equal to 0 for I in range of n, maybe, or is it n? I don't know. Length of scores should be n minus 1 in the number of items in scores, but fine. Oops, did I delete too much? I did. Yeah, I mean, we could do it in a couple of ways, right? Actually, mini is equal to just sum of the first. I was going to write out a for loop, trying to be too clever, but mini is the first k. It's k minus 1, and the maxi is the last k, right? This is going to be n minus k, something like this. Maybe I'm off by 1 here, to be honest. And then just plus weights of 0 plus weights of the last weight, right? I might have to be careful with something like this one. Maybe. K is equal to 2, 1, 2, maybe, I don't know. Well, I guess this doesn't even matter because they get cancelled out, right? So then now it's maxi minus mini. I mean, I'm pretty sure this is right, but except for the off by 1, so that's why I'm putting it out just in case. Why do I not have n defined? I think this negative k is fine too. I think. Like I said, it could be off by 1 or something like this. Maybe off by a lot. Let's print out the scores as well. Maybe I'm just off by like 2 or so. So 4, 6, and 8. yeah. So then we want, so this is actually a 4, so that's good. And then the last is 14, which is not true. So this is this plus 1. Okay. Oh yeah, I forgot to do the plus 1. Okay. So yeah, oops. Let's give it a submit. Hopefully, I mean, it should be good. Oh no. Why is, oh, for n is equal to 1. Oh, for k is equal to 1, this is wrong. Because this is, what is this? I probably wrote it in a better way during the contest. Or maybe not, maybe I got it. But this is, I mean, the idea is right, but clearly maybe this notation is bugging it. Because this should also return 0, but because it's the last, what's negative k? Negative k is, so this is like the last 0. Oh, because this returns to 0. Man, so I guess we can't do the negative notation. It's just like, I mean, that's a silliness, but okay, fine. All right, there we go. Wow, that is actually a really weird edge case, but this is also why I complain a lot about negative indexing. And when I'm in a, I don't know, I need to stop doing that. I mean, I think I complain a lot about negative indexing for that reason, because of all these like weird edge cases that comes up. And in this case, I was just really wrong because what I want is the last 0 element, but instead it started from 0, so now it's all the elements, which is kind of, you know, I almost want to say I never, other than -1, like, or -1 or something like this, like the last element, negative indexing has always been a source of a lot of my bugs, so I don't know why I keep using it, but okay, fine. But yeah, this is linear time, or sorry, linear space, as you can see the scores, and obviously the sorting mix and n log n. The 2 more linear things, but that's fine. Yeah, and you can write them in a for loop to make it k sensitive, but that's really not necessary, clearly. Yeah, that's all I have for this one, I think. Let me know what you think. I think that's I mean, once you have to visualization, is not that bad. Yeah, I did the same thing on the other one. Huh, that's good. And oh yeah, and here I didn't take away the thingy though, but that's fine. Yeah, let me know what you think. Silly mistake aside, I always find a way to, you know, find a bug, even though this was like 98% done by the time I had this bug. So, and like, I don't know, it is what it is. That's all I have for this one. Hopefully, maybe get the bug out of the way and not during the contest. So that's good. So yeah, that's all I have for this one. Let me know what you think. Stay good, stay healthy, to good mental health. Have a great weekend, everybody. Goodbye and take care.